Good afternoon, everyone. Today I will conclude the linear block code part 3, that is the chapter linear block code. So in this section I will consider the next question, the rest two question, that is parity check matrix, how we create a parity check matrix from the generator matrix, and if there is if the received code is given to you, then we can identify the error if present in that code, and the original code word can be reconsidered or reconstructed. So first, to determine the parity check matrix, we have to consider the formula. First, parity matrix, we have to separate the parity matrix from generator matrix, where P equals to this. First, we first identify the parity matrix, then do its transpose. That is, transpose means all row elements are converted into column elements and vice versa. Here 101 is present in the row element and it is converted into column element. So as the both are same number, that's why you may confused with these two matrix, but actually if you carefully notice the scheme, you can see that this one here 101 is converted here as this one is converted here 1, this 0 is converted here, and this one is again converted here. By this process these matrix elements are uh, transferred into the row elements, into the column, from row to column element. That's by this way it becomes to transpose of the matrix. Next, we have to consider the to find the parity check matrix. In parity check matrix, the format is, first I should place the parity matrix transpose form in the first element or the first part of the parity check matrix, and rest of the part, that means total number of bits are 6 here, as because of number of block element is 6. So therefore parity matrix or PT, that means transpose of parity matrix, consisted of 3 bits, 101, 011 and 110. The rest of the parts are created by identity matrix, where I n minus k, that means n is here 6 and k is here 3. So therefore it is I3 matrix. I3 means there is 3 row and 3 column. So by this way parity check matrix is created. Next, we have to consider the error in the receive sequence. Suppose for identifying error, we have to consider this formula: S equals to R into HT, where R is the receive sequence or the coded vector, and S is the error syndrome, and HT is the transpose of parity check matrix. That means here we have to convert it, the parity check matrix, into transpose form. So putting this value, all the value into the equation, we can get this value. So S equals to, here the receive sequence, suppose the receive sequence is 101001. It is given to your question. The parity check matrix, transpose of the parity check matrix is here. You can see that this 101100 is here converted, these row elements are converted here column element. Then we have to consider matrix multiplication. So the matrix multiplication is done here. That means here 1 is multiplied with this one, then it is added to second element, that is 0 into 0. By this way all the first element of the first column of parity check matrix is multiplied with the first element of receive sequence. So it becomes this answer 0. By this way second item and third item are also multiplied. and we get the answer 0, 1, 0. This is called error syndrome. Now we have from error syndrome we have to find out the error position. That means in the bit receive sequence of the bit, uh, in which bit position the error is occurred. Next, to find out the error position, we use transpose of parity check matrix as a syndrome table. So this is the error position and this is the syndrome vectors. Note that if there is no error, then the syndrome vector will be 0, 0, 0. So in your previous question, if the matrix multiplication comes here, if it is come, if it would come 0, 0, 0, s equals to 0, 0, 0, then you may conclude that this question is and the answer is there is no error occurred in the encoding system, and the answer is the receiving code 1. That means receiving sequence is also a code 1. But as here the answer is given, that is error syndrome is given, that is 0, 1, 0. Therefore we have to check that this for this error syndrome the error position occur in which bit. So 0, 1, 0 is seen here. So 0, 1, 0, for corresponding syndrome vector we have to consider the error position, which is here this 0, 0, 0, 0, 1, 0. So after identifying the bit position of the error, we have to calculate this part. That means we have to add it the error sequence with the receiving sequence, and it is done by modulo 2 addition, and the final or the addition of the two vectors will give the original code word. So it is the process, it is right here, that calculated syndrome are checked by the syndrome table to identify the error in the subsequent bit position. So error will be 0, 1, 0. So error position will be this, and by calculating with the formula we can get the original code word 101011. This is the code word. So this is the process where the total question is solved by this way. So hope that you understand. If you have any doubt, so answer me or question me in the forum, in the online session forum. Thank you.